Good afternoon, everyone. Our next talk is by Ryan Carroll. It's Bringing Ideas to Life with IoT, Visualizing Noise Pollution. Please give him a round of applause. Thank you.
Thank you. All right.
I will try to project as best as I can. So I'm not usually a loud person, but I will do my best.
The battery's dying.
Okay.
So
Gotcha.
just a little bit about me, not too much. I've been a full stack developer for a little while. I enjoy that. So IoT kind of stuff is more fun on the side. I think most developers have a Raspberry Pi or something sitting around in a box that they need to put to use. I was just in Andrew's talk and he showed like a whole big box of them. So you'll see throughout these slides that I care about audio and sound quite a bit. That's driven by a few different things. I like to be outside, I like nature, I do a little bit of volunteer audio engineering outside, so that all kind of plays into this. So here's just kind of a little walkthrough of what we're going to talk through and how we're going to get there. We're going to just do a little brief introduction to IoT in case there's anybody that isn't familiar with what it is. And then we're going to talk a little bit about noise pollution through a few different things of why noise pollution is important to me in particular and why I think broader it's important as well. I'm going to do a...
Thank you. Is this better? We're good? All right, I can strain my vocal cords a little less now. So we'll do a little high-level overview of this particular project that I'm showing you today, just the pieces and parts that go into it, and then we're going to dive into those pieces and parts in a little bit more depth, one at a time. We're going to talk through what the results of the project were, and then at the end, bring it together about what this means for you and what this might inspire you to do on your own with your own projects. One thing that I want you to get through this is when it comes to IoT and these different devices and things, there's really a whole world of creative ways that you can apply to technology and fun projects that you can do on your own that you are passionate about and that bring meaning to you and fulfillment. So we'll kind of reference that throughout. But first, I just want to do a brief introduction of what IoT is. So I've got 3 pictures on the screen here. Could anybody tell me, is there anybody brave that wants to tell me what these 3 things have in common? And there could be different answers here. There's no right or wrong, but does anybody want to take a guess at something that these 3 things have in common? Any takers? Yes, in the front. That's right, they are. They are all sensors. So they exist in an environment, and that environment has different factors at play, whether it's wind speed or moisture in the air or it's motion, and they all measure different things about their environment. And on top of that, they're all connected to the internet. So they take measurements from the real world and send that to a server somewhere for that data to be stored and potentially visualized and these different things. And that is what this project is going to do. So I'm going to shift gears for a moment. We're going to spend a little bit of time talking about noise pollution before I switch back to the technology in a moment. So I've mentioned noise pollution a few times. I like this definition here. It is any unwanted or disturbing sound that affects the health and well-being of humans. So noise exists pretty much everywhere, but where it starts to become a problem is that phrase right there in the middle, where it starts to affect the health and well-being of humans. I like this definition also. It kind of expands that and gives it a little more concrete detail, where, to be precise, noise pollution becomes harmful when it extends 75 decibels. And we're going to look at what a decibel is and what that means in a moment, but at 75 is where things start to become a problem. And sleeping is very, very difficult in excess of 30 decibels. So when you're in an environment and you're trying to sleep and get much needed rest for your well-being, talking about that well-being aspect again, it really needs to be 30 decibels or less for that to happen. So before I show some sources, does anybody have any guesses on where noise pollution can come from? What are some things that might cause noise pollution? In the back. Cars, yes, that's a big, big source. That's a very personal source for me, as you'll see very soon, in the front here. Yeah, helicopters, airplanes, all kinds of things, yeah. Pretty much, yeah, especially like that friction and contact is generating lots of noise. I think, yeah, right in the back. Yeah, that's true, very, very true. Especially when the fireworks are at very unwanted times, right? Or in very unwanted places. And you're trying to sleep, it can make sleeping very, very difficult. So you guys covered a lot of them. We got air travel, cars, construction, busy cities. There's lots of different places that noise pollution can come from. So why is noise pollution a problem? Why do I care about noise pollution? Why should you maybe care about noise pollution? And it's really those effects on the health and well-being on people that it kind of falls into some greater problems. So you have a source of noise, and at its surface, it starts to create decreased sleep quality. It can increase annoyance and stress levels, and those can then compound into hypertension. It compounds into reduced productivity, which then contributes to heart disease and some different things. So once you're exposed to enough noise pollution, it really creates a lot of problems. And the European Union has done studies, like actual studies, and they've gathered numbers of how this actually affects people in the real world. And I won't go through all of these numbers here, but it's pretty staggering the number of people that are affected by this. So these are numbers that are just from the EU in the year of 2017. And one of the, I think, most impactful numbers is this DALI number at the end, which is daily adjusted life years, which is how many hours of people's lives have been reduced by the effects of noise pollution. It's really quite staggering when you look at it. And I'll have a link to these slides at the end if you're interested in looking at this any further. So that's why I believe noise pollution is important, and one of the reasons that I think it is a broader concern overall. So shifting gears a little bit, talking more about sound in general, what is a decibel? So I've mentioned decibels a few times, how you need 30 or less to sleep, 75 or more is problematic. And as computer scientists, I find this fascinating, that a decibel is really a logarithmic unit to measure sound. And to help visualize this a little bit, when I say logarithmic, I mean like that intensity really goes up exponentially. So the difference from an 80 decibel sound to a 90 decibel sound is really 10x because of that logarithmic scale that they're measured on. And I'm not going to walk through this graphic in very much detail, but this helps you visualize what number means what. And I mentioned earlier that the 75 level is where things start to cause problems. And the way I like to think about it is, if we were standing outside or in a room trying to have a conversation together, if the noise around us is less than 75 decibels, we're probably going to be able to have a conversation fairly easily. It's not going to be distracting. But if there's loud traffic or loud music or anything like that, and it goes above 75, we're going to have to like be putting our ear close to each other or talking very loudly, and it's just very distracting and not a very productive way to have a conversation. So why did I specifically choose noise? So here's a simple little diagram of my house, and there's an intersection in front of my house. And earlier somebody mentioned cars. So there's a stoplight, and when people stop at that stoplight and they're waiting for it to turn green, when it turns green, oftentimes people like to really mash down that gas pedal, and it makes a lot of noise when they do so. And this started to drive me insane after a while. I actually had the windows in my house replaced because I was losing sleep at night because people with modified exhausts or motorcycles were being so loud, and the noise was just coming straight through my windows that for many months I was really irritable because I was not getting sleep. And we saw some of the health effects of that earlier. So that is noise pollution. Now we're going to talk about the project a little bit and get into the technical side of things. So I'm going to start by talking about the hardware, and then we'll look at the software. So like any good computer scientist, I have a Raspberry Pi at home. I have several, and I am guessing that several of you have Raspberry Pis at home as well, and they need a good project. They don't want to just sit on the shelf all the time. They want to do things. So this is what I decided to do with mine. So I got a Raspberry Pi, and I got an attachment for it called an environment meter. And this is a neat little piece of hardware that you can just put right onto the top of your Raspberry Pi, and it's got lots of fun sensors on it. It has a humidity sensor, a temperature sensor, air quality, and it has a microphone. And the microphone is mainly what I was after. So this might be a little bit overkill for just needing a microphone, but I wanted to be able to do lots of things with it later on, so that's what I chose. And then inside my home, I have a little server as well that I'm using to store all the data that we're going to look at in a moment. So the server itself doesn't matter too much what it is, just that it's a computer that you can use to store all of your things with. And this is what it looks like on my back porch, just a really dark picture that doesn't really show you a whole lot, but you can see that it's reading the decibel values there. I will give a shout out here. I'm not associated with either of these, but if you're looking for fun things to pair with your Raspberry Pi to get some sensors going, Adafruit and Pimoroni are both good online stores that have a lot of different options, and they're fairly accessible. So with that, I'm going to move to the software portion. And we start with Python. So we're here today because we all love Python. We all love all of the different things that you can do with Python and how flexible it is. So the backbone of this project is Python. And I'm using Python to interface with the sensors on the Raspberry Pi that you saw, and we'll take a little bit of a look in a moment as to what that script looks like. But Python is here. We've got InfluxDB, which is how I am storing the data, and I'll talk about why I chose Influx in a moment. I'm using Grafana for the visualization piece, and then most of it is running in Docker. So hopefully most of us are familiar with Docker. If you're not familiar with Docker, you should definitely look into it. Just like Raspberry Pis, it's a tinkerer's best friend. It can help you do a lot of things easily. So, bringing all of the hardware together, here's my super fancy diagram of what it all looks like. You've got a loud car. It's honking its horn. It's squealing its tires, just causing havoc in my backyard. And I've got the sensor out on my back porch, which sends the data over to Influx, which is read by Grafana. It's all stored on the server, and anybody can hit that dashboard with their web browser of choice. So we will dive into the details of each piece for just a moment. So the script, the Python script, I will say that I did a lot of digging around on the internet. I found an open source script that helped me out quite a bit. So some of the code that you're going to see is mine, and some of it is open source code that I used because, as it turns out, converting a sound signal into decibels is very, very, very complicated. It is tremendously more complicated than I thought it would be, but the internet is very helpful sometimes. So here I am setting up the input stream from the microphone and capturing that. I won't go through this in too much detail, but this is just connecting to the microphone on the sensor. And then it is a process to get to a decibel value. So you first want to get what is the root mean squared from the signal, which is just a single value that really represents the energy levels across a range. So if you think about sound, it is a wave, which is represented on a ranged scale, and you need to see how much energy is in that range. And then once you get that, you can convert it to sound pressure level, and that involves a little bit of math. And once you get the sound pressure level, you can convert it to a decibel value. And then once I convert it to a decibel value, I send it over to Influx. So I'll mention it in a moment, but Influx has a very nice Python library that makes it very easy to use. You just set up your connection fairly easily with some credentials and tag your data and send it over, and it's pretty simple. The data itself looks a little bit like this. I know that might be a little hard to see, but it's got some tags on it. I'm setting what type of data it is, where it was collected from. There's a value that represents what the decibel value is. Just a couple things that I want to mention about it, because this is important for the database piece, but it is high volume data, which means every second I'm collecting a decibel value. So there's a lot of it. And as you scale a system like that up, if you have multiple sites that you're collecting data from, or maybe you're collecting it even more often than a second, you have to think that's a lot of data that's coming in. So you have a system that needs to be able to handle a high volume of data. It's also time-stamped data. It's data that exists in time, so time is very important, which I'll expand on in a moment. And it's denormalized. And that's just a fancy data word that means I'm kind of storing all the data together in the same table and everything about that data, which is typically what you do in a analysis type situation, which is what I was doing. So because of many of these reasons, I chose to use InfluxDB, which is a time series database. So before I started this project, I didn't know time series databases were a thing. I'm just familiar with like Postgres and SQL Server and a little bit of NoSQL, but there are special databases out there that are purpose-built for this kind of data to handle that high volume, time-stamped, analytical type of data. So it's good for multi-source data if you have different sites that you want to collect data from or different sensors. It's good for expressive data, so if you're tagging your data with different values, where the data is coming from, what the type of data is, those types of things. It has really good support for client libraries that I already mentioned. It works very well with Python, and it works well with Grafana, which we're going to talk about in a moment. And there's the Grafana integration, and it has really good community support. Just as like a little side note, when you're doing hobby projects on the side, it's very important that you choose projects and libraries that have good community support. Because when you run into a problem and you're trying to figure something out, usually you don't have a team of people that you're working with. You don't have a senior developer that you can necessarily go to and say, I'm having this problem. It's very specific. It's with this thing. And senior developer says, oh, you're just doing this one really simple thing wrong. You don't really have that when you're on your own. So you're kind of at the mercy of the documentation and the other people that are finding problems. So just a little side note as you're looking for your own adventures. And then it has downsampling support. So downsampling just means that over time, I'm going to reduce the density of my data. So maybe I'm collecting a reading every second, but data that is a year old, maybe I just want to average that out to each hour instead of every second, because that older data is not quite as important to me. And that will help you with data storage, because you have to think if you're storing all of this, that data is going to grow in size over time. And something that I accidentally did when I worked on this script the first time is I forgot to put a sleep in there. So I want to collect 1 reading per second, but I didn't put a sleep in my script. So you know what it did? It took like a bajillion readings per second, and it was just like absolutely destroying my database with all of that data. So I had to do a lot of downsampling with that at first. So that's InfluxDB. How I ran it, I use Docker, so I'm a big fan of Docker. Docker Compose makes things really easy, makes life simple. So there's my Docker Compose file. By the way, all the code for this is going to be in the GitHub repo, and I'll have a QR code for that with the slides at the end if you're interested in doing any of this yourself. So use Docker Compose, created a bucket, which is just a storage place for the data. I generated an API key to authorize my requests from Python into the database, and I use the Influx library. So nothing too complicated there. And then I sent those readings, and oh yeah, it's open source, by the way. I forgot to mention that earlier. So now we're going to talk about Grafana. So Grafana is how I visualized the data after I stored it in InfluxDB. And Grafana is easy to use. It's built for observability and metrics. It's typically used in like system performance monitoring type situations of like how much CPU or RAM is my server using, but you can really use it for anything. And it's open source and free and easy to use, so I would encourage that. It's got a lot of data visualizations just out of the box that you can use fairly easily. And it's open source, which we like. As Python users, we should hopefully like open source software. So Grafana, I'm running it in Docker as well. I've got a Docker Compose file for that keeps it up and running. So similar story here, I'm configuring it, and then it's got a nice user interface that you can log into and start building your dashboard visually, and you can build fun charts with it. So the result, I have a demo that will never go wrong if you try to do it live. So I think I've got a couple minutes. We can take a look at it before we wrap up. I think I'm going to have to exit this. And I did not think about the fact that this is 2 different screens. So let's see. Where does... I don't know how to get it over there. Let's see. Is it that way? It is that way. All right. I will just have to crane my head while I'm doing this. That's okay. So this is my dashboard. It's at my house right now. And you can see the decibels that it's recording at the moment. Right now we're looking at the last 6 hours. We can see that something really loud happened a little after lunchtime. I'm not there, so I don't know what that is, but that's pretty significant. We can scroll down and see my all-time high is 97 decibels. That was a lightning strike a year or so ago. The highest rating in the last 6 hours was 96, which was probably that spike that we saw a moment ago. I've got some daily averages. Wednesday and Thursday were kind of loud, but they're all fairly similar to each other. This fun chart tells me per day how many times it went above 80. It's a little messed up right now, so it's showing more than the last 7 days. It's actually showing like all of time right now, but some averages. And these are the visualizations that I put together. So there was actually a thunderstorm last night where I live. So if we do the last 24 hours, it was in the evening. So if we zoom in here, you can see what a thunderstorm looks like. There's some lightning right there, some more lightning and rumbles. You can see it was kind of spicy for a little while, and then eventually it petered out. So if I go back, and let's do a week. See what a week looks like. So a week, you can kind of see the day-night cycles a little bit, where it spikes and it's getting kind of busy in the morning, and then as you get to the middle of the night, it goes down, and then as morning comes, it stays pretty hot and heavy throughout the day and then dips down for the night, and you can kind of see that cadence as it goes throughout the day. All right, so I've got just a few minutes left, but that is the demo. Now I'm going to try to get back to the slides. We're going to see how this works. All right, perfect. All right, so what's next? What can I do with this project? I always like thinking ahead. Starting simple is good, and I think that you should start simple, but if I wanted to expand this project, and this is where I like to get the creative juices flowing and think, where could this go? What else could you do with this kind of pattern? So I could always deploy to additional sites. I've got a meter at my house. My parents live out in the countryside a little bit more. I have friends that live further in the city, so I could put a bunch of these meters out there and feed them all to my dashboard and see how they compare with each other. I could build an action plan or a proposal for the city or the municipality because now I have data. I'm not just some crazy guy saying, hey, it's really loud, but here's exactly how loud it is, and here's what science says as to how it's affecting people. It's always more powerful when you have concrete data that you can point to. Machine learning and AI is all the rage right now, and if you want to build a model, what do you need for it? You need a lot of data. And how cool would it be to build a machine learning model out of your own data that you collected that is meaningful to you? You could do some weather and noise correlation to see if there's a pattern. You could look for patterns in the data and you could apply some machine learning there. You could see if there's a time-noise correlation. You could identify the source or the type of noise. So maybe I build a dashboard that says this many cars passed by, this many trucks passed by, this many motorcycles. There's a lot of like fun things that you can do once you get the juices flowing and think, all right, what can I do with this data next? And now I want to point the question to you. What is it that you care about? What kind of data matters to you? How might you use this same type of architecture of sensor, database, visualization to power something that you're interested in? Couple ideas. These are not exhaustive, but maybe just to get the gears flowing a little bit. You could do UV or air quality. You could correlate those things together. You could track them independently. You could track wildlife. Maybe if you have wildlife in your yard, you could point a camera at it and identify, I've got this many deer, I've got this many foxes or what have you, or birds. You could track bird types or number of birds in your yard. You could monitor the pH levels in your water supply or in your garden or the groundwater. You could track the soil moisture for your garden. You could maybe correlate that to plant growth. So there's all kinds of things that you can do with data and tracking data. And I hope that maybe this inspires you a little bit to do a project of your own. One last slide here, just a couple little closing thoughts and tidbits, is always stay curious. There's always something interesting in the world around you if you will look for it. You just have to keep your eyes open and look for those things and always be curious. Never just be satisfied with the status quo. When you're embarking on a project, make sure you pace yourself. It's not necessarily going to be easy, especially if you're doing it by yourself with technology that's new to you. So expect this might take a while. I might run into problems. Be patient along those same lines and start small. You don't have to go for the world right away, but start with something. So with that, We're not doing questions. Well, we're not doing questions here, but I will be outside of this room back there. If you have any questions or thoughts you would like to share, there's that QR code. Again, it will take you to the code base, and you could do this yourself if you wanted to. So with that, that's all I got.